Hey guys, welcome to Unit 1, Lesson 3, and we're going to get into some more new stuff today. We're going to start off by talking about the placement of when you have an initial side and a terminal side. So just remember, this is your initial side, and this is your terminal side. And notice how your vertex is at 0, 0, and we're going to place this on the coordinate plane. So if you'll notice this R, that is going to be representative of your radius. So let's think about if we're going around the unit circle or the coordinate plane, we make a circle. And so R is going to be the radius of that circle. If we go so far over, that's your X value. If we go so far up, that's your Y value. And notice how it makes this beautiful right triangle. And your coordinate point, so let's kind of put some numbers. So this is 5, this was 4. Your coordinate point out here would be 5, 4. And so that's really going to come into play when we talk about these trig functions. So you learned in geometry about sine, cosine, and tangent. So we're going to jump down here. So sine, don't forget SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. What these three are is they're the reciprocals of sine, cosine, and tangent. So cosecant looks like this. It's the reciprocal of sine. Secant, SEC, that's a reciprocal of cosine. And then cotangent, COT, is a reciprocal of tangent. So when we come down here, instead of having opposite over hypotenuse, we're going to have hypotenuse over opposite. Hypotenuse over adjacent, and adjacent over opposite. Okay, so I also want to, I'm going to change colors here. I'm also going to come up here and we're going to apply. So, for instance, if sine is opposite over hypotenuse, we're also going to apply these letters, and that's going to be important later on. So sine is not only opposite over hypotenuse now, it's also y over r. So I'm going to do that to all 6 trig functions. Okay, so we have this. And so I want you to start training your brain not only to look at these trig functions as this, but also this new information as that. Okay, so now we're going to solve some problems here. So we have this point, 815. So I want you to look at it like this. So we are going to just plot it. So 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. So we're right here at 815. So we went 8 over and 15 up. And what that does is that makes, so here's this, our terminal side going through this point, and it makes a right triangle. So what the question is asking is find the values of the 6 trig functions. Okay, so let's kind of review. So this is our x value, which is also our adjacent. This is our y value, which is also our opposite. And this is our r value, which is also our hypotenuse. So notice that we're missing this value here. So you learned in geometry that you need to do Pythagoreans Theorem to find that. So instead of saying a squared plus b squared equals c squared, in trig, we're going to say r squared plus y squared equals r squared and solve for that r. So I showed my work here and I found out that this missing piece is 17. So now I'm going to solve my 6 trig functions. So I have sine of theta, and theta is going to be a variable that we use in like in trigonometry. So instead of like x, a lot of times we'll use theta, and it usually represents like an angle measure. And it's spelled theta. Okay, so sine is opposite over hypotenuse, or y over r. So I'm going to say 15 over 17. So I'm going to complete the rest of them. Okay, so notice that I really focused on these three, and you should be familiar with that from geometry. And then for these reciprocal functions, I just flipped it. I just found the reciprocal of the value. So go ahead and try example 2 on your own. Now notice -3, -4, it's going to be down in this quadrant. So just see what you can do with that. Okay, so I did this problem. If you'll notice my picture over here, I did keep the negative numbers, and that's important. It's more about showing a location. Now, the only thing that is always going to be positive is this hypotenuse here. So I made a note of this. Make sure that you know that, because it's truly the radius of this like portion of the circle that we're creating. So radius is a distance, so it always has to be positive. Okay, other than that, I did Pythagoreans Theorem, and I found these 6 trig functions. So go ahead and try these 2 on your own and see what you get. Okay, so for number 1, they're wanting you to find an angle in standard position. So again, standard position has vertex here and initial side right here, and it goes through the given point. So I made my own graph because I thought that was really small. Over here. So notice I went through the point 36, and that is my angle. For number 2, I know it just said to find the tangent, but I just want to kind of talk through some things. You do not have to draw out a triangle. So if you're good at the X, Y, R stuff that I was telling you about, like here, you can just look at this and do Pythagoreans Theorem on those and quickly find R, and then just plug it in. So that Y over R is sine, this is cosine, and so forth and so on. So I kind of modeled that here. Also, the last thing is you can't have a square root in the denominator, so you have to rationalize the square root. So don't forget to do that. So like I'm doing this one right here, so it ends up being 4 square root of 41 over 40. Okay, so let's go ahead and move on. So now we're going to talk about finding the trig functions at a quadrantal angle. So remember, quadrantal angles are these angles right here, where like the terminal side is on these points. So let's talk about that. So in this case, this is a really good example that knowing like the X, Y, and R's will help you. It's very beneficial. So when you have a 90-degree angle, this is the first time that you don't have this nice X, Y, and R thing going on. So because notice there's no like R or anything like that. So what you're going to do is just pick a point on that 90-degree line. And you can call it anything you want. I just keep with zeros and ones. So what is this point? Well, it could be 0, 1, it could be 0, 5, it could be 0, 100, but 0 and a positive number. Okay, so if we think about this, this is X and this is Y. So I'm looking for R. R is going to be the same length as whatever this value is. So for simplicity's sake, I'll just keep that 1. So sine is going to be Y over R. So then I can just fill in 1 over 1, which is 1. So go ahead and kind of work through the next trig functions. Okay, when I did this, I came up with these values. And so again, I'm just using X, Y, and R as kind of my guide. So I showed you how I set those up here. So if you get confused on which one is 0 and which one is undefined, 0 on top is okay, 0 on bottom is no way. So this one is going to be undefined because you have the 0 on the bottom. However, when I come over here and flip this, that 0 becomes on top. So the reciprocal of undefined in this case would be 0. Go ahead and try example 4 on your own. Notice that instead of giving you a degree, it gives you a point. So if this is x and y, my r is going to match whatever that value is, because it's the distance one. It can't be the 0 one, it will be the distance one. So it's going to be 3. Remember, r is always positive, so that's why it's a positive 3. So go ahead and try the 6 trig values there. Okay, so I have these is my answer, and again, I use the x, y, and r as kind of my guide. Okay, so on this next example, we are going to use these values. Notice these are all quadrantal angles that we're dealing with, and apply them to evaluate these expressions. So I want you to kind of look down here. So I've shown you how to do, let's go back up here. 90 degrees, and also I didn't point this out a while ago, this is 180 degrees. So you could have just, if you put theta, that was okay too, but it's the same thing. Okay, so we've done this one, and we've done this one, and so you can easily replicate these 3. So I would just advise you to just practice those and make sure that you can get all these values okay. And if you have any issues, please let me know. But we're going to use this as kind of our guide. So when you have the tangent of 0, so I'm going to use this chart down here. So the tangent of 0 is 0. And the sine of 90 degrees is 1. And so, again, we're just using this new concept to apply to evaluate these expressions. So try B and C. Okay, so I want to point out a couple things. First of all, in trig, this is the same thing as this. It's just written kind of weird, so I want you to become comfortable with that. What you're going to do is you're going to take the sine of 360 and then square it, and the cosine of 360 and then square it. So we're going to see this notation a lot. I always find it kind of confusing. The next thing I wanted to say is, like, this n, it means, like, for the rotation, we've kind of talked about before. Every single time you rotate, so this one rotation, two rotations, we're going to have the same value of cosine. So it doesn't matter what that n is. You can just put in 1 for an example. So cosine of 61. So go ahead and just practice. Try not to use the chart. Just kind of practice with x, y's, and r's and see what you get on these 2 problems. Okay, guys, so I tried to make notes as I went along. So this is negative 270. So it's not down here, it's actually up here because I'm going negative 90, 180, 270. So that's where I got my value. So it's really the sine of 90 degrees. That's another way to look at it. This one, I added 360 to it, and I got negative 90. You're more than welcome to add another 360 and get 270. It doesn't matter. Either way, you're going to end up at this point right here. So that's where I got my information. And then down here, this is, I figured out that this was a 0 degree angle or 360 degrees. So however you want to look at this, however way makes the most sense to you, I just kind of showed my work there. And that is it for lesson 3.